This time on Werner's Whirligigs, we're going to align the tailstock on the combo lathe, and we're also going to repair the cast iron pulley that goes on the motor. So stay tuned. I want you all to remember that I'm just another yokel who's not educated nor a professional in what I'm doing here, and it's possible that if you rely on this video, you, your project, or the both of you might end up as a smoldering hunk of hammered dog shit. Please use common sense, be careful, and always protect your ears, eyes, face, body, and hands when doing this type of work. With that, let's keep on trucking. This video may contain peanuts. Hey everyone, welcome back, or welcome to Werner's Whirligigs. This time I don't have too much additional information to share at the beginning of the video, so we're going to jump right in. I will say one thing, I've placed some Easter eggs in the video for you guys, and so you'll have to pay attention or go looking for them if you want to see them. I'm not even going to tell you what they're about. Alright, let's go. Getting the tailstock mounted is fairly straightforward. Got it sitting here upside down right now. I'll just put some whey oil on the jib here. And might as well smear around some on the ways here as well. Okay, so one other thing we're gonna add here is this little pin. And this allows you to lock the tailstock into place. The jib is just for keeping it straight while it slides. But when it's time to lock this thing into place, so it doesn't slip while you're doing cuts, you want to use this part. Okay, so everything's in there. Here we go. So we get it in here like so. And we're going to pick it up, turn it over, set it on here. Okay, something's not right there. You can tighten that up a little bit more. I'm rocking it back and forth here. Make sure there's all the free play is taken up. Okay, and then we want to lock it up. It's now locked up, and now it moves. Okay, this is good to go. Just when you thought you'd heard it all and couldn't stand any more about this electrical box, I redid it again. That will be, I think, the 6th time. And I ultimately did it because I decided that having the wire lead come out this direction would be the best. Not enough room here on the right side. In the back, it was getting pinched down here between this bracket and the main body of the lathe. So finally I ran it like that, and the wire now loops down and goes into the hole in the bottom side of the lathe body until it connects to the switch in the front of the lathe. And since I had to redo that, the original wire was already a little bit short, and it was hard to connect up to the switches when I was putting things back together, so I actually extended it by another 8 inches, I think, to make sure it would never be an issue. And that's good news, because we need to take the switches out in order to do the headstock and tailstock alignment. So that's where we're going next. Here we are, starting to work on alignment. I'm going to get the camera in here as best I can, so you can see our headstock here, our tailstock here. I'm going to introduce you to the tools that we'll need. we're going to need a live center. A live center is one that has a spinning head on it. We're also going to need a dead center. The live center is going to go in the tailstock. The dead center, which doesn't spin, is going to go in the headstock, inside the spindle. The tailstock has a Morse taper 3. The headstock has a Morse taper 4. We're also going to use this Edge Technology Tailstock Alignment bar. Pull that out and show it to you. You can buy these on, Amazon, and they're great. It's a really simple tool. You can make your own, but to buy a piece of steel that's this big and to cut it without a taper can be a challenge. So buying one that's perfect already is not a bad deal. I can't remember. I think they're maybe like 50 or 60 bucks. And then we're going to need an indicator and a mag base as well. So let's get started here. We're going to mount the live center in the tailstock, and let's just clean it off first. Make sure nothing gets in the way. Make sure it's nice and straight and true. Okay, now we're going to clean up the dead center. And I've already done this before, so it's there's not too much to worry about here. And then it goes into the head, into the spindle. And finally, we're going to take the alignment bar and place it in between the two and tighten up the tailstock, or crank out the tailstock until it captures the bar in between the two. So now with the live center here and the dead center here, as we rotate the chuck and the spindle, well, there's no chuck here, as we rotate the spindle, this is driving this bar to rotate, and this one is spinning inside of its bearing here and allowing this to rotate without impairment. So let's step back now that we're here and answer the question, why bother aligning your lathe? I mean, it sounds like a good idea, but why would you do that? Well, if your tailstock is out behind or in front of the center point of your spindle here, and you go to turn a bar like this, it's going to end up with a taper. So if these are exactly lined up, the diameter of this left point here and the diameter of this right point here as you turn this bar will be identical. However, if the tailstock is too far forward, then your cutter, which is going to be sitting here, is going to be taking more of a bite out of this end than when it gets scrolled over to here. And conversely, if this is too far back, when the cutter, my fingertip is supposed to be the cutter, is here ready to take a bite, it'll be taking less of a bite out of the cylinder than it is over here. And so you'll end up with a taper with a point pointing this way, versus if it's too far back, you'll end up a taper where it gets wider here or narrower down to here. So we want to make sure that the two ends are lined up so that when we go to turn a long steel cylinder like this, that the diameter is going to be the same and consistent throughout the length of the piece that we're working on. The precision parts of this tool are the two rings at either end. So each of these is supposed to be exactly an inch. And I've got my tool here set on an inch, my calipers or my micrometer, and yep, that's perfect. And this feels really good too. Okay, so since that's the case, if we put my magnetic base with the dial indicator on it and mount it to my table here, move the table over to here, take a reading, and then move the table over to here and take another reading. If these two are lined up correctly, then the readings should be identical. So let's go ahead and do that. Now that we have things lined up, we're going to place my mag base and my dial indicator on the table. It's locked into place. And then we're going to zero the reading by moving the cross slide. Okay, now we're on 0. So now we need to take the table, slide it all the way to the other end, and take a reading. And what we get over there will tell us how far off we are. Well, for just a moment I forgot myself and thought that I lived in the lovely world where everything works out in the end. But I encountered several problems that I had to deal with in order to take the next step, to run the table back and forth from right to left. Unfortunately, I can't run the entire length of the bar and take measurements using the table here. The first thing that happened was I ran into the motor. The second thing was that I ran into the cover that went on the lead screw, and even after both of those were removed, I just did not have enough room. So I was coming up about an 1.5 inches short. So now what I've done is I've mounted the compound rest up here. Okay, so off camera, I took some time to make sure that this thing is aligned exactly parallel to the waves on the lathe. So now what I can do is I can put my indicator and mag base on the back of the compound slide, and when I run out of travel in the table, then I can get that last 1.5 inches using the compound slide. All right, so we're going to give that a shot now. Now you might be saying, well, that sounds great, but how did you line up the compound slide to be parallel with the ways? Were you just going to breeze right past that and not describe it? No. So here's what we do. I've got my indicator and the mag base here. I'm mounting it onto the compound slide, and I'm placing it at a point where it is touching the bottom of the ways. Okay, now that we have the mag base mounted to the compound slide and we have the indicator on the bottom of the ways, we're going to use the cross slide to dial in the needle to 0. And then we're going to turn the cross slide in the direction towards the camera, to the left. And you can see as I turn it, the needle remains stationary. I've already gone through and done this process off camera, and any change that might be occurring in the video would be a function of parallax. Ha ha ha. I feel like anytime anybody says that, they're lying. They're like, I have error. These are not the droids you're looking for. This is parallax error. But believe me, I spent a good 20 minutes on this making it right. So now, with this in place, I should be able to move the cross slide, or the table, all the way back to one side, move the compound slide back all the way, and then take a reading on the far circle, the far disc, and then drive it all the way across and take a reading on the disc closest to the left side. And that should give us an indication of whether the two are lined up. Here we are now ready to take a reading. We have the indicator on the disc here. I'll spin the disc really quick once around. There is a little bit of run out, less than 1,000th. The next thing we're going to do is start cranking on the lead screw to move the entire table across the ways. So notice that the indicator has fallen off to 62 thousandths, and that's because the diameter of the burgundy part of the tool is a smaller diameter. So we're going to crank this all the way as far as it will go, and keep an eye on the indicator, because it will change if things aren't lined up, and I can already see that the numbers are increasing. Alright, now we're going to switch over to the compound slide to take the last of the travel. Let's just double check that. Okay, so we're showing about 12.5, maybe 13 thousandths of difference between the disc on the tailstock end and the disc on the headstock end. And that means that the headstock is 12.5 thousandths closer to the indicator than the tailstock end. So we have a fair amount of offset here that we need to address. How are we going to address this? We can do it one of two ways. Well, we can do it two of two ways, actually. We can move the headstock, or we can move the tailstock. By move, I mean forward and backwards. Now, the tailstock is specifically designed so that you can move it back and forth, not only to make this alignment possible, but also for times where you actually would like to cut a taper and want to have some offset. The headstock, on the other hand, isn't really set up for this, for making that type of change. However, given the fact that we've taken it off and put it back on, what I'd like to do is just go in and check the settings, loosen it up, move it around, and put it back into its position before assuming that the tailstock is that far off. So perhaps the headstock didn't slide quite right back into the correct place. So we're going to give that a look now. All right, we're going to begin by removing the switch plate again. And actually, since everybody knows how this goes together, I'm not going to record it, and I'm going to come back in a moment when it's off. So backing up, the headstock isn't adjustable per se. It really is designed to be tightened up and fall into a single position. There's two screws here, two set screws that push on a jib, and on the other side, there's no jib, and it just sits squarely on the ways. I'm just going to loosen things up a little bit and just check where things sit, and then we'll go from there. I've also left the indicator in place up on the alignment tool, just so that I can monitor any changes that occur during this little exercise. And of course, you're not really seeing much of anything because I'm working underneath the machine where, not even I can see. Okay, so that's loose. Then let's loosen these up a little bit. Theoretically, that should allow us to push this back just a hair. Let's see. Yep, and sure enough, that's what happened. I pushed it back, and while you can't see it, the indicator is now showing that the headstock is only 5 thousandths out of alignment instead of 12 thousandths out of alignment. But unfortunately, we can't tighten it up that way, and we also can't tell if it's going to be aligned correctly in this orientation. So really the best we can do is tighten this all back up. And in doing so, it came back into 12 thousandths of an inch. And we're going to go in and tighten the bolts under there and move over to the tailstock. And I'm going to do that work cleaning things up here off camera. All right, I got things buttoned up. Everything, we're back basically where we started. The indicator is showing 12 thousandths of an inch off of center, so that above zero, excuse me, that means that, again, we're 12 thousandths closer to this ring than we are to the one on the right side. So what I'm going to do is back it out to zero again, and now we're just going to go in the other direction. We're going to run across to the other side, and at that point we're going to take another reading and confirm that we're 12 thousandths off when we're on the other end. Now I'll be quiet so we can fast forward through all of this hand cranking. Okay, and there we are. And well, it's not perfect, saying that we are 11 thousandths off. When we went the other direction, we were 12 thousandths off. But that's, for the moment, close enough. Of course, we're going to have to take another reading after we make changes. So for now, we're going to leave it here, and what we're going to do is adjust the tailstock and try to get this reading back up to zero. So let me get set up for that, and then we'll come back. Let's talk procedure a little bit and pieces. So the tailstock has multiple pieces, but we're worried about two at the moment. There is a piece, a lower piece, which attaches the tailstock to the lathe. And then there's this upper piece, and these two pieces are separated here, and they can move back and forth in this plane. So what we're going to do first is loosen this bolt, and there's an identical one on the other side. And then there's an adjustment bolt right here, and there's another one on the other side. So we're going to want to move it in that direction. So what we'll do is go over to the other side, loosen that bolt a little bit, and then we'll tighten this one an equal amount, which will drive the tailstock in that direction, and we'll continue to do that with very small adjustments until we get back to the 0 point. Now, one other thing I'll show you real quick. I'm going to release the camera from the stand, show you my finger. You guys like that? This is on the machine right now, and essentially it's saying it's right at 0. So it'll be interesting to see how far that moves after we've moved the tailstock 12 thousandths towards the front of the lathe. Okay, we're set up now. I've arranged the camera so that you can actually see the dial indicator while I'm doing the work. So the first thing I'm going to do is loosen these two bolts, which clamp the top of the tailstock to the bottom of the tailstock. And just for those who aren't familiar with bigger machines, this is pretty much very similar to the way you do it on a big 20 by 80 lathe. Similar kind of process. These things are held together. You loosen and tighten to readjust things to get them centered up. So let's see. We're going to want this front one. We want the whole thing to come this way. So I'm going to just take a little bit off of this one. I'm going to walk around to the other side of the lathe. and I'm going to attempt to push this forward. Now I say attempt because it kind of looks like it's been painted together. I could be wrong. In a perfect world, that would start moving. And, you know, it's very possible. I could be going backwards, actually. I'm not sure. Hopefully we just get any movement. And then if it's in the wrong direction, we'll go on the other way. But at least that tightened and loosened up. So when I loosened up the first side, then came over and tightened up the second side, when I went back to the first side, it was tight. Okay, there it goes. Do you see it? All right. We're there. We're at 0. Now let's come back around and see if we tighten this one. Theoretically, it should go off of alignment. Yep. So let's just well, that's funny. We've gone too far. So I feel like I should want to push this one back in to push across. I feel like there's a little bit of a question mark over how these things work. I guess another strategy would be to get it to where it's supposed to be, tighten up the clamp bolts so nothing can move. Of course, but of course that's changing now that I've got it lined up. So as I'm, well, let's see, let's just this side just to where it's starting to get some resistance. Pull it this way. Let's hit this one and see if it comes back in this direction. And it is. Okay. Okay, now these are tight, so let me see if I tighten up this now. It shouldn't make any change. Oh, it did a little bit. All right, not exactly right. I'm gonna fiddle with it off camera a little bit. Actually, no, let's just leave it on. I probably, whoops, I'm going the wrong way. But that got us, oh, that's funny. So when I tightened it, it got on center there, and then I did something in it. Okay, actually, I'm glad I didn't turn the camera off, because now we're on 0. So we're back in position. Let's do this again. Okay, we're set on 0 here. Let me just triple check. Yep, everything's okay. Well, whoops, I put the camera stand in the way. Okay, so, all right, hopefully we can still see everything. And now I can get all the way through without bumping into the camera stand. All right, so now let's start moving in the compound rest because I've almost run out of room on the lead screw. I actually clamp down a little bit, so I'm just loosening up the hair. Can you let me go further? That's too further, yes, there. All right, fingers crossed. Wow. All right. I can't believe it. It worked. I'm not the kind of guy that things go right for. So I'm pretty stoked. So now, by this measurement, the tailstock and the headstock are within line with one another. That's fantastic. I'll just share one other thing with you too about the headstock. On a larger lathe, you will see adjustments for the headstock. However, usually I say that, but I don't believe it's actually in this plane. It's rotational. So the whole lathe, the whole headstock can move a small amount of degrees in either direction to make sure that it is truly lined up with the tailstock. We don't really have that adjustment on here. We could do it with shims if we needed to. And I'll have to think about that. But at this point, I'm not going to get into it for this video. So, in conclusion, that's how we align the headstock and the tailstock on pretty much any lathe, no matter of its size. It's a similar or the same procedure. One last detail here is that scale again on the tailstock, and you can see that 12 thousandths did show up on the scale. So we have moved the top mark against the bottom mark. Now that we've got the alignment out of the way, we're going to work on repairing this pulley. This is the motor pulley, and as I showed you before, we've got a big chunk missing here. We also have a pretty major crack here, and eventually this one's going to come apart, and this one's going to probably wear the belt prematurely and cut it up. So we need to take care of these, and how we're going to do it is we're going to earthquake. No, I'm just kidding. We're going to add silicon bronze in this hole or gap and build it back up, and then take it over to the lathe and cut it straight again. Same thing here, except we're just going to grind out this crack as best that we can, and hopefully we don't make it fall apart. If we do, that's not a big problem. And then we'll put some braze on here as well. So we'll just start with this one. The reason for the welding angles is that I'm just going to use it to help stand it up straight while I work on it. I don't have to do a lot here, but I just need to get rid of some of this paint. Okay, I think that one's cleaned up enough. Alright, for the second one, I'm using a slightly duller tip. I'm not sure why. I guess my gut's telling me to be careful. You know, I don't want to drill a hole through here with a point all too quickly and end up in China or something. So we'll try this one here. Alright, so here you can see, put a pretty good groove in there through the crack, where the crack is, so there's more meat for the braze to hang on to. The other side, I mean, I can barely see in there, but I've just cleaned it out, removed metal the best that I can. And then on this piece here, the bigger chunk that was missing, I've just removed metal in all of the surrounding area so that the brazing material will stick to it. Okay, we are go here for welding up the pulley. In one of my earlier videos about repairing the lever on my surface grinder, I afterwards noted two errors that I'd made. One was that I did not clean the material adequately. It did not cut a groove into it. You've already seen I did put a groove into here, so that issue's been addressed. And the second one is that I did not give it time to cool. So I've got a couple of buckets of sand standing ready, and once I finish with this, I'm not welding, I'm actually brazing. So once I finish brazing, I will put the part into the sand and let it cool. So first, before we do anything, we need to heat this thing up. Love the pop. Running for 350 to 400 degrees. Somewhere between 350 and 500. Sounds good to me. Got my TIG welder, got my silicone braze. See what kind of trouble we can get into here. Piece of wood is just to prop up my hand so I can get it closer up to the level of the part. Whoops. Oh my goodness. Alright. Well, I just created a bigger problem. Dang it. I'm starting to grind this puddle down. It's grinding like cast iron just by looking at the color of the sparks. Alright, it's a new day, different overalls, and what we saw yesterday was the finest example of hammered dog shit. I've done this before a little bit, back when I was repairing my surface grinder, and I read my notes and thought I knew what I was doing, but the reality was I didn't. I'm in recovery mode now. I did a bunch of reading last night online, and I also watched some videos and went back and read my manual some more for my TIG welder. And you know what I did yesterday, I believe? Even though I knew I was brazing, I believe that I was thinking about melting the base metal, developing a pool in the base metal, and then dabbing in the filler rod, which is not the way you braze. The way you braze, at least for cast iron, is that you preheat the base metal up to 600 degrees plus or minus, and then you use the TIG torch as a heat supply to heat it more up to, I believe it's 1900 degrees, which is the melting point of these filler rods, and then you allow it to flow onto the base metal without melting it. I had my torch set at 125 amps, and even though it was pulsing, that was way too much. I think I'm going to start around 70 today, just because it's relatively thin piece since it's a pulley. And what else? Yeah, I'm just going to try DC welding without pulse using my pedal at about 70 amps, maybe up to 80, and see how that works. Pulley is 1998, 1999 vintage, most likely from China. Maybe not the best cast iron in the world, probably has a fair amount of impurities in it. And you can see that there's been a lot of pitting in here. There were some cratering and stuff. So that could have been me, but it could also have been caused by some impurities. I'm not sure at this point. I mean, if I had to guess, I'd say it's probably me. All right, we're trying this again. Let's put some heat on it first. When I was welding on my surface grinder part, I remember it started to get a little bit cherry red right when it was getting up to a better point of temperature. Alright, I'm seeing like high 4s to mid 5s now. Again, I'm kind of aiming for 600. I see a little bit of red around the edge of the pulley. There we go, now it's getting red. One more time. It said 550. One point it said high. That was a new one on me. I guess I don't know what the limit of this is. Alright. As I said in the earlier part of the video, I'm going with straight DC TIG No pulse. I'm going to start with 75 amps. And what I need to do is just warm up the metal a little bit more. Not till it melts, like last time, but just enough to take some of this off. So I'm going to just place this right here. Let's go. Jeez. That just starts to crater right through it. Let's take it down to 65 amps and see what happens. I feel like I'm missing something here. I don't know why I'm getting so much soot and corrosion, and it's just not heating up right. Like, I'm going to drop it down to 55 amps just to see if I can get more control, because I just feel like I don't have control. It's making a puddle too fast. See what happens when we clean it up. Yeah, I mean, it looks awful. I'm hoping that maybe somebody who knows more about this than I do can weigh in on what the problem is here. The other thing I did yesterday, I took my entire torch apart. I took the hose off. I checked it for leaks. I could, check to make sure that the gas is making it through. It certainly is, because it kind of looks like the shielding gas isn't there. And that's working a little better. So I've got the heat down to like 55 amps now. Now, if you were to go look in the Webster Merriam Dictionary under hammered dog shit, next to the picture of me, you would see something that looked kind of like this. My welding job here. I did not do the best job of getting that silicon bronze on there, but at least I got it to a point where it is larger than the area of the hole. And same on the other end up here. So before I take this over to the lathe, I'm going to just hit it with a flap disc for a bit and get off these high spots. First thing we're going to do here is tell you what we're doing. So I'm going to use this rod here as a mounting post for the pulley. So first I need to turn it down so the outer diameter is the same as the inner diameter of the pulley. And then we'll mount that on here and come back and use the lathe to turn down the new metal that I've applied onto that pulley. So we're going to start putting a center hole on this right here so we can mount it up to my tailstock. We got the pulley here, and I want the pulley to be as close to this point as possible. I'm still going to use the center, the live center, to hold it, but still I think it's going to be more stable if it's closer to the chuck here. I feel like I just had too much hang out there, so I'm going to set it right about here, and that's going to give me more stability. So let's tighten up the chuck. And we're going to center drill the hole again. Okay. We'll get rid of this drill. Bring in my live center. Oop. I know this thing looks janky, but I've run my indicator over all my live centers, and this one is this. Yeah, this one has almost 0.000 run out. Impressive. So start here. And only the center part, this outside doesn't turn, only this little part here. So let's slow it down and just make sure everything's okay. Yeah, that looks good. And I'm going to make a reminder mark on here where I want to put my shoulder for the back side of this. And I actually need to leave some room for some threads in case I want to put a nut on here. I may not have to because there's a set screw in here that will center or will clamp onto the shaft. I guess that pen just is giving up the ghost. Alrighty. I'm actually going to take a little bit out of this, out of the tailstock. I'm going to keep it closer. All right, we're rolling. I thought we were rolling before. I've had this problem, and we weren't. So I've already cut this down from 1 inch to about, I think it's about 3/4 of an inch in diameter now. 725 thousandths. I need to get to 625 or 5/8 of an inch. So we'll just keep going here. I'm just switching cutters right now. That's how I realized I wasn't rolling. Let's see here. So we need another 100. So I'm just going to zero this out right now. And so I know where I am. We'll take a modest bite, 30 thousandths, just to see how this thing turns. It's a little bit better looking than what we had before. Okay, I'm just have to bring it in over here because I don't have enough room. Actually, let's step up the speed. Try it again. Not bad. It looked a little bit better slow. All right, let's take a reading again. 649 thousandths. All right, that means we need to go 24 more thousandths. Let me bring you up to speed. The camera shut off again. You didn't miss much. I just took a cut, and I'm now down to 635 thousandths, and I need to be at 625 or 0.625, which is 5/8 of an inch. So we're close. We need to do 10 more thousandths, and yeah, I know exactly where I need to be. I'm trusting my dials, and we're going to take that last cut right now, and then we're going to start cleaning things up. I might have to take another skim off just a little bit more, just because I don't want this to be a press fit. I want this to be, I wouldn't call it loose, but I don't want it wobbling. Okay, so let's try that. Okay, let's see what we got. 625, right where we wanted to be. Like I said, I think that's going to be a little bit too large, but we'll try. But before I do that, I'm going to just clean the shoulder up a little bit manually. Let's also just sneak in here really quick and put a bevel on the end. Back out the center. Like I said, I think this is going to be slightly too big, but I'd like to stop and check it now. No? No? Perfect. That's pretty much exactly what I wanted. So the pulley's back on the shaft. The live center's in here. Let's see. This definitely tightens down. So I was going to put a nut on the end. It's going to make some threads and put a nut on there, but I don't think it's necessary. So we've got a good fit. We've got this thing clamped on. All right, let's turn it up and see what happens. Let's have another look. All right, well, we're bringing it down slowly. And I'm just going in with the compound instead of with the lead screw. All right, another peek. Let's work on the outside of this thing real quick. Okay, just well, this is somewhat satisfying at least. Let's work on that part. I went through a couple more rounds of adding silicon bronze and cutting it off with the lathe. It got kind of repetitive, and I'm sorry that I didn't do a better job of recording the work that I was doing in the actually in the sheaves, I think they're called, of the pulley itself. It was difficult for me to get a good angle, and I Also, I'll be honest, I just at the moment didn't think about the fact that my camera and its position wouldn't be able to see down to the cutter. So you really didn't miss much. You saw the beginnings of it, and I think you get an idea of what was going on. I'm really happy with the way it turned out. It's not perfect, but it's good enough. Good enough for me. I'm just going to throw some paint on it, but here you can see this is pretty good. Like I said, not perfect. And then on the back side, that's looking pretty good too. So like I said, I'm just going to throw some brick red paint on it to make it look somewhat original. And then we'll reinstall it and start making some chips on the next video. Early on, I mentioned some Easter eggs in the video. Unfortunately, my family suffered loss in the Los Angeles fires that occurred this week and are still occurring. My mother-in-law lost her house. We had to evacuate, but our house is still standing. I'm sitting in my shop now post-fire, but it was really scary, really, really scary. One of the fires started right up the street from us, and I thought we might lose our house. So I've just got some videos that I shot from the roof when I was hosing it down, and also in the street in front of our house before we evacuated. That's going to wrap this one up. Thank you for your interest, especially if you stayed tuned for this long. If you enjoyed this video, I will always appreciate a thumbs up. Doesn't cost you anything except a few seconds of your time. And subscribe if you like. I'll be back with more content in 10 days. I guess I'll close with, I'm happy to be alive. I'm happy that we had no loss. I'm really sad for my family members that did, but that's the way life goes. So until next time, so long for now.